Okay, so part 2, we're going to be looking at the effect of A. Okay, so we're going to remember that our basic format for exponential functions is f of x equals a times b to the x power. And from the last activity, we noticed that the b was the ratio, and the a seemed to have something, maybe there was a first term type thing happening there. Okay. However, now we're going to be looking to see how the a affects things. So we'll be able to see a little bit better about a as the first term and how that kind of works. All right, so let's start with number 10. So again, I'm going to rewrite this just so we can visualize what the a is and what the b is. So the a is still 1, but now the b is 2. We actually did this on the last activity, so we're not going to go through all the math that we have to do here. We're just going to go ahead and use what we had from the other table and get this graphed. And you'll notice on my graphs, I'm not writing f of x, I'm writing y, and that's just because of room. Okay. All right, so let's go to 11. So now things start to change up a little bit. My a is 3 and my b is 2. So now it looks like my b is staying the same, but my a is changing. So let's do a little bit of our calculations over here. So for -1, I would have 3 times 2 to the negative first power. Nothing wrong with my 3, but 2 to the negative first power needs to become 1 over 2 to the first. So I end up getting 3 over 2, or 1.5. Now let's go ahead and do the math for the next one and kind of start seeing what our pattern is. Last time the b was the ratio, so I am going to try to make an educated decision and think, okay, well, I'm guessing that my next term is going to be 3, because if I multiply 1.5 by 2, I get 3. But let's continue and do the math on the side just to be sure. So this becomes 3 times 1, because anything to the 0 power is 1, and I get 3. So this is still following our geometric sequence, right? As my x is increased by 1, I'm using my ratio to change my y. So I can now assume, and correctly assume, that if I multiply 3 by 2, I'll get my next point. 6 times 2 is 12. That's my next point. And if we look, we talked on the last section about maybe when x is 0, that's kind of considered the first term here. And my a is 3. And at 0, I have a 3. At 0, I have a 1. My a is 1. So it sounds like our theory, where the a is like our first term at 0, that kind of holds true here. So let's go ahead and graph. So now our y-intercept is changing. Okay, number 12. Our a is 0.5 and our b is 2. We're going to fill this table out a little bit faster. So according to this, my a is also the y-intercept. Okay, we're starting to see that for sure. Thought maybe that was the case before, but now we know for sure. And we also know we have a geometric sequence. My x's are increasing by 1. So I'm going to be doubling everything because my ratio is 2. And then let's graph. All right. Now, number 13 says, how does positive A, so this means positive, so how does A being positive affect the graph of the equation? Y-intercept and behavior, domain and range. We're not going to quite talk about domain and range yet, but we can talk about the y-intercept. So now we're seeing that the A actually determines the y-intercept. The reason that we never saw it change on the other page was because the A was constantly 1. So the A determines the y-intercept. If the A is positive, the y-intercept will be positive. And something else we see on the graph is our end behavior. If we look from left to right, our curve is increasing. So we're going to make a note about that too. So let's go to the next page. We're going to fill these out a lot faster. Now, I don't have a distinctive number here listed as the A, but a couple things to remember. The negative is not to the x power, just the 2. If there were parentheses around the negative and the 2, it would be different, but there's not. So only the 2 is to the x power. What's really happening here is we have -1 times 2 to the x. So be very careful. Remember, that's why we spent all that time talking about the difference between a negative within the parentheses and not with our exponents. So my A is -1, my B is 2. Now from the last set of tables, we realize that this 0 is our y-intercept and so is the A. My ratio is 2, so I'm just going to double. And then we'll graph. Okay, that's a new shape that we haven't seen yet. And then number 15. Same process, label our A and the B. Our A is our y-intercept, we have found. B is our ratio, so we're going to double. Then back it up and we get -1.5. So remember, our x's are going by 1s, so the geometric sequence will follow with the ratio. And then go ahead and graph. And I don't have -12 here, but it's close enough where we can make our best guesstimate there. And our last one, my A is negative 0.5, the B is still 2. So my y-intercept here is going to be negative 0.5, negative 1, negative 2, and we're going to back this up. And then graph it. All right. So how does, oh, that's supposed to be negative. How does a negative A affect the graph? Okay, it still determines the y-intercept, but now if the A is negative, the y-intercept is negative, our curve is decreasing, and if we look here, if we compare our graphs, they're not mirror images going left to right, they're actually mirror images up and down, right? So they're essentially the same graph when the A is positive or negative, but if it's positive, it curves up, and if it's negative, it curves down. So that's something also to think about as we move forward and start seeing how these different parts of the equation or the function create different graphs.